Hi, and welcome to Fulbright Library. Luckily for you, our in and out library kiosk has just arrived this morning and is ready to serve. But first, let's talk over a little bit about how this kiosk was created. So, as an introduction, this kiosk was ideated when I came to a Fulbright library to borrow a book for casual light reading. As an introvert myself, it was inconvenient to have to ask for the librarians to check the book out for me because this requires them to scan my student ID, then manually update the book that I borrow out of the system, and only after that I was able to take the book away. So I asked myself, what do they need? How can I make this process faster? And that's when I came up with the motivation to create a library kiosk for checking in and out books from the library. As you can see here, my visualization of a kiosk, which includes a place for scanning student ID, a control panel to make new borrow or return requests, a place for scanning books, and a display screen. And over here is a kiosk that can be commonly found at public or college libraries in foreign countries, but rarely in Vietnam. Under the constraints for circuit-verse implementation, the scope of this kiosk needs to be narrowed down, in which the overall logic design would be as follows. The book count will start at 0, and each student is allowed to return one book at a time and borrow one book at a time. Whenever there's the borrow request, which means B equals 1, the book count is increased by 1, and in contrast, whenever there's a return request, the book count is reduced by 1. Some exceptions are, at book count 0, you can only borrow to move on to the book count equals 1. If any other requests are made, the book counts remain 0. Secondly, if the book count is 3, you will receive an error if you try to borrow one more book. The error only goes away when you return a book. Using the finite state machine diagram as I just showed, I chose to use more machine to better control the output. With all that said, now is the design flow that I used to approach the creation of this kiosk. First step is to figure out the combinational logic circuits for the state transition and the outputs. Next is implementing the master-slave flip-flop to create a 3-bit memory and also to avoid propagation delay. Third is create the 3-bit memory from the master-slave flip-flop for storing states. And last but not least, a decoder to decode the 3 bits of the states into 4 bits for digital display. Now comes the truth table. The logic I just explained remains the same. However, in this truth table, I also take care of the invalid values such as states beyond 100. For example, 101. If somehow the states are invalid, there's always be a trigger to go back to book count 0 to reset. Here's the state transition K-map, which is not too simplified, and here are the logic expressions for state transitions, as well as the combinational logic circuit implementation on circuit-verse. Let's now move on to the output truth table. Our outputs includes 2 lights, green and red, indicating whether we are allowed to borrow more books. As you can see here, when the book count reaches 3, which is 011, borrow request is enabled. Besides, I also turn the outlier bits combination into an error, which indicates invalid values. Here are the logic expressions for outputs green and red, as well as the circuit implementation on circuit-verse of these 2 outputs. Next is the creation of the master-slave flip-flop, and since the flip-flop only account for 1 bit, I use 3 master-slave flip-flops to create a 3-bit memory in order to store the states. Lastly is the decoder truth table. In order to display the book counts along with the states, I created a decoder from 3 bits to 4 bits of digital display in order to indicate if it's at state 0 and the book count is 0, then the display will display the number 0. Except when it is an error, when you borrow over the book limits, it will show an E. And if the state accidentally goes into some invalid values, the indication would be letter F. For us to debug as well as to know what is going on with the circuits. And again, here are the logic expressions for the decoder as well as the circuit verse implementation of the decoder. Now let's put them all together. So let's come to our real circuit. Here is the entirety of the circuit where we have input B and R over here and a feedback loop of N1 and N2, N1, and N0 go back into our logic circuits. Here we have a write enable to click from 0 to 1 whenever you want to make a new request, and a 3-bit memory to store the bits. After the bits go through the logic circuit over here, it will go into a decoder where you decode it so that it can display the 4-bit display of the 0, 1, 2, 3, E, and F. And over here, we have two LEDs, which are green and red, and here are the logic circuits for the outputs. So in order to use this, we would go to this tab here, use Kiosk here, to make it more user-friendly. So the way that you use this is you would first make your choice of B and R, and then turn new request to 0 and then 1. It would jump into the next states. So whenever you want to make a new request, you would go to 0 and then 1, and that's, you have 2 books now. And then if I go 0 and 1, it would go to 3, and if I go one more, it would have an error value because the maximum book count we can borrow is 3. So that's error. And the only way to go back from E is to return 1 book, because if you keep adding, it will stay at E. So now I'm gonna put R, meaning return 1 book, and B to 0. And that would increase the book count to 3, 2 to 1, and to 0. And if at any states, if at any states you, for example, state 1, you have the borrow and return equal to each other, it would stay at that states until you change this, and that would change the book count to 2, which is state 2. And that's it. And about the LED display, let me increase it up to 3. That's when it indicates that if you borrow 1 more book, an error will occur. So that's what the LED light means. If I increase it back to 2, it means that yes, you can borrow more because you only add 2. And that's it. That's how the story of the in and out library kiosk begin and end. I hope you enjoy using the library in and out kiosk to return and borrow your books without having to talk to anyone. Thank you.